One of the most alarming things that many people notice after turning 60 isn't just a few wrinkles or slower steps. It's when the mind starts to slip, forgetting names, misplacing keys, losing focus mid-sentence. It's frightening because it feels like losing a part of who we are. But what if I told you that memory decline isn't simply urging? It's biological, often reversible, and strongly linked to lifestyle and brain health. Let's explore what's really happening inside your brain. Right, so let's start with something we often overlook. The brain is not a static organ. It's living, breathing tissue changing every second of your life. When we talk about memory decline after 60, we tend to imagine it as something inevitable, something that just happens because of age. But that's not quite the full picture. What really happens is a gradual shift in how the brain maintains and repairs itself. From around your mid-50s, small biological changes begin to accumulate. Blood flow to the brain can decrease slightly. The cells that protect and nourish neurons slow down their repair work, and the balance of essential chemicals that carry signals from one neuron to another begins to fluctuate. These are subtle, but over time they add up. Imagine the brain as a city, a busy, interconnected system of roads, lights, and communication lines. When we're young, those roads are smooth, traffic moves freely, and repairs happen almost instantly. But with age, tiny cracks form in the pavement. The traffic lights don't always switch at the right time, and communication between different areas becomes a bit slower, not because the city is failing, but because maintenance crews aren't as quick as they used to be. This slowing of communication inside the brain is one of the earliest signs of cognitive change. Now, memory relies on a very specific part of that city, the hippocampus. It's the area responsible for converting short-term memories into long-term ones, and it's also one of the most energy-hungry regions of the brain. As we age, the hippocampus can shrink slightly, sometimes by as much as 1% a year after 60. That might sound small, but in a system as delicate as the brain, it makes a big difference. The interesting thing, though, is that this change is not uniform. In some people, memory remains sharp and active well into their 80s. In others, the decline is much faster. So the question becomes, what's the difference between the two? Part of the answer lies in something called neuroplasticity, the brain's ability to reorganize itself by forming new connections. When you learn a new skill, read a book, or even take a different route on your daily walk, you're stimulating neuroplasticity. It's like opening new roads in that brain city. The trouble is, after 60, we often stop doing these things. Routines become repetitive, habits settle in, and the brain gets less stimulation. Without challenge, those neural pathways weaken. It's a bit like a muscle that isn't used. It slowly loses strength. But there's another layer to this story, one that's often invisible until we really look closely. The brain's blood supply, the intricate network of arteries that deliver oxygen and glucose, becomes less efficient over time. These vessels stiffen, reducing the smooth flow that the brain depends on. When that happens, neurons get less energy and memory formation suffers. It's not that the brain can't remember, it's that it doesn't have the resources to do so effectively. Add to that the impact of poor sleep, chronic stress, or even mild dehydration, and you start to see how fragile the balance really is. And let's talk about something that doesn't get enough attention: inflammation. Over decades, the body's immune system can become overactive, producing low levels of inflammation that quietly affect the brain. This kind of chronic inflammation damages cells and interferes with the chemical signals neurons use to communicate. In other words, it creates static in the system. So while you might be trying to remember a name or recall a story, your brain's connections are literally being interrupted by biological noise. Now, the good news, and it really is good news, is that this decline can be slowed, sometimes dramatically. The brain is remarkably resilient. Even in later life, new connections can form, damaged areas can adapt, and function can improve. But this depends heavily on how we live. Physical activity, for example, increases blood flow to the brain and stimulates the release of growth factors that help neurons survive and thrive. Just a brisk walk, 20 or 30 minutes a day, can make measurable changes in brain structure over time. Diet also plays a critical role. The brain is made up largely of fat, healthy fat, and it depends on omega-3 fatty acids and other nutrients to build cell membranes and maintain signaling. Diets rich in fish, nuts, olive oil, and leafy greens provide exactly that. Meanwhile, excessive sugar and processed foods do the opposite, promoting inflammation and oxidative stress that accelerate brain aging. So when someone says, "You are what you eat," it's not just a saying. It's a biological reality that's clearly visible under a microscope. Let's pause for a moment and think about how this feels from the inside. You wake up one morning, walk into the kitchen, and can't quite remember what you came in for. You meet someone familiar, but their name just won't come to you. It's frustrating, and it shakes your confidence. But what's happening behind that feeling is an extraordinary biological process. Your neurons are still firing, millions of them per second, but their coordination has slipped. The speed and strength of those electrical signals have dulled slightly. It's like a choir that's lost its conductor for a moment. The music is still there, but it's disorganized. This is why mental exercise is just as important as physical. Reading, solving puzzles, learning new languages, even socializing, these all stimulate different networks in the brain. And that stimulation acts as a kind of fertilizer for memory. The more we use those circuits, the stronger they become. But it's not only about keeping busy, it's about meaningful engagement. Watching television, for instance, is passive. But discussing a complex topic, teaching someone else, or picking up a new hobby demands active mental participation. That's what makes the difference. Another major factor we often overlook is sleep. During deep sleep, the brain performs a kind of housekeeping. It clears out toxins, consolidates memories, and resets its chemical balance. If sleep is disrupted, and for many people over 60 it often is, that cleansing process doesn't happen properly. Over time, this buildup of waste proteins can interfere with memory and attention. You could think of it as trying to work on a computer that's never been restarted. It still functions, but it slows, freezes, and makes mistakes. Now, there's also the matter of hormones. As we age, levels of certain hormones that protect brain cells, like estrogen and testosterone, decline. These hormones don't just influence the body, they directly affect brain chemistry and plasticity. This is one reason why post-menopausal women, for instance, may notice subtle cognitive changes. The brain is adapting to a new hormonal environment, and that transition takes time and support. Nutrition, exercise, and mental activity all help in maintaining balance during these shifts. One of the most fascinating aspects of studying memory decline is how differently people experience it. You can have two individuals, both 65, both with similar lifestyles on the surface, yet one has a sharp, lively mind and the other struggles with forgetfulness. When you dig deeper, you often find differences in lifelong habits. One may have stayed socially engaged, continued learning, stayed physically active, while the other became more isolated or sedentary. These small, cumulative differences are what define brain health later in life. There's also the emotional component. Chronic stress releases cortisol, a hormone that in small doses helps us respond to challenges. But in excess, it becomes harmful, damaging neurons in the hippocampus and impairing memory. It's not just psychological, it's physical. This is why relaxation techniques, mindfulness, or even simple breathing exercises have measurable effects on brain structure. Reducing stress helps the brain repair and restore itself. As we move further into the discussion, it's important to recognize that not all memory loss is the same. Forgetting where you placed your glasses is very different from forgetting what glasses are for. Age-related memory decline is usually about retrieval. You know the information is there, but it takes longer to access. Pathological decline, like dementia, involves the actual loss of information. Understanding this difference helps reduce unnecessary fear and encourages proactive action. When people begin to notice memory changes, the first reaction is often anxiety. But ironically, that anxiety can make things worse. When the brain is under pressure, it prioritizes survival responses over memory processing. This is why you might forget simple things when you're stressed or rushed. So one of the simplest yet most effective steps is to slow down. Give your mind space to recall, rather than forcing it under tension. Another point that's often overlooked is hydration. The brain is about 75% water. Even mild dehydration, the kind you might not even notice, can impair concentration and short-term memory. As we age, our sense of thirst diminishes, so we often don't drink enough. It's a small detail, but a critical one. Keeping hydrated supports optimal blood flow and electrical activity in the brain. Let's come back to the bigger picture. Memory decline is not just a symptom of aging, it's a reflection of how well the body and brain are being maintained. Every choice, from what we eat, to how we move, to how we rest, influences the brain's internal environment. When we nurture that environment, the brain responds. It's constantly adapting, repairing and rewiring itself, and even at 60, 70, or 80, it's capable of remarkable recovery. If we look at populations that age gracefully, where elders remain sharp and engaged, we often find a pattern. They stay active, eat whole foods, maintain social ties, and keep learning. Their brains are not spared from aging, but they're supported through it. The difference is not genetics or luck, but daily habits practiced consistently over years. So when we talk about stopping or slowing memory decline, what we're really talking about is sustaining the biological conditions that allow the brain to thrive. This means good circulation, balanced nutrition, quality sleep, regular stimulation, and emotional stability. It's not one miracle cure. It's a network of small, powerful actions working together. And perhaps the most hopeful part of all this is that improvement can begin at any age. Even if memory has already started to slip, the brain can still respond. In studies of older adults who began simple exercise routines, measurable increases in hippocampal volume were seen within months. That means actual growth in the brain area responsible for memory. This isn't theoretical, it's observable biology. So as you sit here, perhaps thinking of moments when your memory faltered. Remember this, it's not the end of the story. The decline is not destiny. Your brain is alive, adaptable, and responsive to care. The key is to understand what's happening inside it and to take steps, however small, to support its natural ability to heal. And when you think of memory not as something that fades, but as something that can be strengthened, you start to view aging itself differently. It's not about losing capacity, but about maintaining the systems that keep you who you are. Every walk you take, every new thing you learn, every good night's sleep, it's not just a routine. It's an act of preservation. The science of memory decline after 60 isn't a story of loss, it's a story of resilience, regeneration, and the profound ability of the human brain to keep learning, adapting, and growing for as long as we live. Now, when we begin to understand the brain as something alive and responsive, not static or predetermined, it changes how we see our future. Because if decline isn't inevitable, then what we're really facing after 60 is a choice, a biological crossroad between neglect and renewal. The brain never stops learning. Every sensory signal, every conversation, every new experience still shapes it, even now. The question is whether we feed it enough of the right signals to keep those neural networks alive. Let's look deeper inside the process that allows this regeneration to happen. Within the brain, there are specialized cells called glial cells. They're like the support crew for neurons, cleaning debris, repairing damage, and maintaining balance in the brain's microenvironment. For decades, scientists thought glial cells were passive helpers, but we now know they're active participants in learning and memory. When you challenge your mind, these glial cells spring into action, pruning weak connections and strengthening useful ones. It's a biological dance of adaptation. The more you engage with the world, the more vibrant and efficient this process becomes. But of course, the opposite is also true. When mental engagement slows, when days become repetitive, when curiosity fades, the pruning continues, but in the wrong direction. The brain becomes more efficient at doing less. Networks that aren't used are literally dismantled. This is one reason why retirement, though freeing, can sometimes trigger a noticeable mental slowdown. Without the structure of daily challenges or problem solving, the brain's maintenance crew starts packing away the unused circuits. That's why purpose, even in later life, isn't just a psychological need, it's a biological necessity. Now imagine for a moment the daily chemistry inside the aging brain. Electrical impulses firing along axons, neurotransmitters like dopamine and acetylcholine flowing across synapses. These are the messengers of thought and memory. But over time, production of these chemicals can slow. Acetylcholine, for instance, is critical for forming new memories, yet its supply tends to decrease with age. This slowdown makes it harder to encode fresh information. That's why older adults often say, "I can remember things from years ago perfectly, but not what I had for breakfast." The storage system still works, but the input mechanism has weakened. Yet here again there's hope. The production of these neurotransmitters can be stimulated by both physical and mental activity. Aerobic exercise increases the availability of oxygen and glucose, the brain's primary fuels, while mental challenge keeps the chemical pathways for learning active. It's a constant loop. The body supports the brain, and the brain in turn drives the body. When one slows, the other follows. Let's consider blood flow again, because it's one of the most powerful and underestimated factors in maintaining memory. Each heartbeat sends about a fifth of your blood straight to the brain. That flow delivers oxygen, glucose, and nutrients, but it also removes waste products. When arteries harden or become partially blocked, that exchange weakens. Over the years, even a small reduction in circulation can reduce cognitive sharpness. You might notice it not as confusion, but as subtle fatigue, a lack of focus or a delay in word recall. It's not the mind failing. It's the brain asking for better supply lines. That's why cardiovascular health and brain health are inseparable. The same habits that protect the heart, movement, diet, hydration, sleep, directly safeguard memory. Exercise in particular stimulates something extraordinary called brain-derived neurotrophic factor, or BDNF. Think of BDNF as the brain's growth fertilizer. It encourages the birth of new neurons and strengthens existing connections. In older adults who maintain active lifestyles, levels of BDNF remain high, which helps the hippocampus resist shrinkage. You can almost imagine those neurons sprouting tiny new branches, finding new paths to communicate. Now, if we zoom out from biology for a moment, there's also a social and emotional dimension to memory that's equally powerful. The human brain evolved in connection with others. Conversation, storytelling, laughter, empathy. All of these are deeply neurological experiences. When we isolate ourselves, those experiences fade, and with them, so does stimulation in key brain regions. That's why loneliness, especially in later life, isn't just sad, it's damaging. Social isolation increases the risk of cognitive decline almost as much as smoking or obesity. But when you sit with someone and truly engage, when you recall shared memories, debate, or simply listen, you're lighting up entire networks of association, emotion, and language. And it's not only about preventing decline, it's about identity. Memory isn't just data storage. It's the story of who we are. Each experience, each relationship becomes part of that internal narrative. When memory weakens, that story begins to fragment, and that's what makes it so frightening. But it also means that protecting memory isn't simply about keeping facts intact. It's about preserving the self. Let's take a quiet look at the emotional reality of this. Imagine an older man, perhaps in his 70s, standing in a kitchen he's lived in for 40 years. The smell of coffee, the sound of a clock ticking, these things are familiar, comforting. But he pauses, trying to remember where he put the sugar bowl. It's a simple lapse, but for a moment he feels disoriented, unsure. That flicker of confusion doesn't just frustrate him, it unsettles something deeper. Because memory is the thread that holds daily life together. Yet here's the remarkable thing. If he then takes a breath, recalls yesterday's pattern, traces back his steps, and the memory clicks into place, his brain has just performed a small miracle. It has rebuilt the link, strengthened the circuit. That's how recovery begins, not through grand gestures, but through small acts of awareness repeated over time. Now, there's another dimension that's becoming clearer through brain imaging. The connection between emotion and memory. The amygdala, the brain's emotional center, works closely with the hippocampus. When an experience is emotionally charged, it's remembered more vividly. That's why we recall moments of joy, fear, or sadness so clearly even decades later. As we age, emotional regulation changes, often becoming more stable, but also sometimes more subdued. Without those peaks of emotion, the brain doesn't tag memories as strongly. That means part of improving memory isn't just mental, it's about engaging emotionally again. Music, art, conversation, even gratitude. These stimulate the amygdala and make experiences more memorable. Let's return to sleep, because it ties everything together. During the night, the brain enters cycles of activity where short-term memories from the day are replayed and organized into long-term storage. It's like a librarian sorting and shelving books. If sleep is cut short, that sorting is incomplete. Bits of information remain scattered, harder to retrieve later. In people over 60, sleep patterns often become lighter or more fragmented, but improving sleep hygiene, consistent timing, limiting caffeine, ensuring darkness can restore much of that lost efficiency, and when it does, mental clarity improves noticeably within weeks. Another piece of the puzzle lies in metabolism. The brain uses about 20% of the body's energy, mostly from glucose. But as we age, cells can become less efficient at using glucose. This is sometimes called brain energy deficit, and it's linked to forgetfulness and brain fog. Interestingly, certain fats, like those found in olive oil and nuts, provide alternative fuel in the form of ketones, which the aging brain can use effectively. That's why balanced, nutrient-dense eating patterns make such a visible difference in mental sharpness. Over the last few years, researchers have begun to see how lifestyle changes can physically alter the aging brain. Imaging scans show that after just a few months of consistent exercise, areas related to memory and attention actually grow thicker. The electrical activity between regions becomes more synchronized. This isn't theory, it's visible transformation. What's even more striking is that emotional well-being follows the same pattern. As cognitive health improves, anxiety and depression often decrease. It's as if the brain, once sluggish, rediscovers its rhythm and confidence. But there's also a challenge here. Habits built over decades don't change overnight. It takes awareness and patience. Many people expect instant results when they begin new routines, but brain repair is subtle. The first changes might not appear as sharper memory, but as better mood, steadier focus, or easier sleep. Then gradually the quickness of recall, the fluidity of conversation begins to return. The most successful transformations come from those who treat their brains as living gardens, watered daily, tended carefully. Given time, there's one more aspect that deserves attention: curiosity. Curiosity is the spark that drives learning, and it doesn't have an expiration date. In older adults who continue exploring new subjects, traveling, or even asking questions about the world, cognitive decline slows significantly. The act of wondering, of seeking, keeps the brain engaged. It reminds us that age doesn't define capability. The mind, when given purpose, refuses to stagnate. Now imagine, for a moment, how this all fits together inside one person's life. A woman in her early 70s begins to notice she's misplacing words more often. She decides to start walking every morning, reading in the afternoon, and cooking healthier meals in the evening. At first, nothing changes, but within months, her energy rises. Her thinking feels lighter. Names come to her more quickly. She laughs more, sleeps more deeply, and feels, for the first time in years, in control of her own mind. That's the quiet power of biological repair, slow, unseen, but absolutely real. As we move through life, the accumulation of small choices shapes the future of our brains. And when we understand how sensitive this organ is, how it thrives on oxygen, nutrients, movement, challenge, and connection, we begin to realize that decline is not fate, it's feedback. Every forgotten word, every mental fog is the brain signaling what it needs. The tragedy isn't in the decline itself, but in ignoring that message. There's something deeply empowering about that, because if decline can be influenced, then so can renewal. It's not about chasing youth, but about protecting clarity, focus, and independence. About being present, truly present, in your own life, no matter your age. The science of memory decline after 60 isn't a grim story about inevitable loss. It's a call to action. A reminder that the most complex organ in the known universe still responds to your care, still grows when nurtured, still remembers how to heal. And perhaps that's the greatest lesson of all. The human brain, even after 60, is still learning, still adapting, still capable of astonishing recovery. Memory is not a fading light, it's a living flame that can be rekindled with movement, curiosity, nourishment, rest and love. The sooner we understand that, the longer we stay ourselves, the longer we remain whole.